this is a classic capacitor combination problem in the homework there, and it says the following here. If you have a 20, a 30, and a 25 microfarad capacitor, I didn't draw the units on this one here, capacitor sitting in a system like this here, how could you combine them into one single big capacitor using sort of what we know about how capacitors combine? The way you have to handle this is just sort of piece by piece, and you have to do a bit of pattern recognition to see sort of how these capacitors combine. So as this one sits, there's nothing you can do with it right now. It's just sitting there. It's a 25 microfarad capacitor. But these two right here are actually in series, and you know you can always combine capacitors in series in the following way here. You can say that the C total for two capacitors in series is 1 over, say, 1 over 20 plus 1 over 30. So that's one of the equations we covered in class. You can find in your book just about how capacitors in series are combined. I know they're in series because if I imagine I'm like a little electron or a little inspector going through the circuit here, as I start and travel down this circuit right here, there's absolutely no options I can take in terms of turning away from the path these capacitors are sort of on. Like I must go from here through this capacitor, on and out again. There's no left or right turns I can make, and so that's how I know they're in series here. And if I sort of combine these two things in series here, the total that I'll get for that is 12 microfarads. So I can redraw the circuit then to look something like this. I can have a battery like this, and I can draw just one capacitor here now, not two, and then just one capacitor there again, not two again. And now, well, what of this capacitor? Well, nothing's changed with this one. This is still the 25 microfarads, but now this one is the series combination of these two. So this will be a 12 microfarad capacitor just like that. And so this is what my circuit's become now. This is still a battery over here, by the way. So this is like a plus and minus V, and a plus or minus V has no bearing on the problem at all, other than it's just sort of driving the circuit there. Lastly now, what can I do now? Do I stop? Do I go on? Well, no, I can go on, because now the new 12 and the 25 are in parallel. How do I know they're in parallel? Because there's some symmetry here. This line here is all connected across the positive V. This line down here is all connected to the minus V. I notice that the top plate of the 12 and the top plate of the 25 are both connected to that positive V. Likewise, the negative down here, this negative supply, are both connected to the two bottom plates. So whenever the top plates are the same potential and the bottom plates are the same potential, that's the definition of parallel for capacitors. So combining them in parallel is actually easier than series here. In particular, I just add them when they're in parallel. So my final circuit then is going to look like this and like this, where 12 plus 25 is a 37 microfarads. So this circuit with one battery and a 37 microfarad capacitor is electrically exactly equivalent to this entire circuit. You could replace the 20 to 30 in parallel and 25, this whole bunch right here, this whole bulk right here, with just one capacitor that has 37 microfarads of capacitance. And that's the way that problem would be worked.